Conditions has given Norwegian suppliers a unique engineering and marine competence.
Offshore wind energy really started in the North Sea. That is because there were good governments that really liked those type of technologies.
We are proud in Norway of the creativity and innovation of the offshore energy industry.
There's a new revolution coming, using floating technologies for offshore wind. That will allow us to go further offshore, hunt better wind speeds in deeper waters, and reduce the environmental footprint further.
Our skilled supply chain is creating innovative and efficient cost reduction solutions and better services. Norway has value to add in offshore wind. We're open to collaboration, and the Norwegian offshore industry's strong reputation in health and safety standards makes us a trusted partner in this global development. Norwegian offshore expertise, taking offshore wind further.
So we should see Jon now, right?
Yeah, please. My name is Jon Dugstad, and I'm the head of Offshore Wind at Norwegian Energy Partners. As you will have seen in the film that was just shown to you, the Norwegian industry is well prepared to deliver value-enhancing solutions to the international development of offshore wind, and particularly so to the Taiwanese projects. Norwegian companies are used to work in harsh environments in the North Sea, and experience is now developed to support projects also in Taiwan, ranging from environmental analysis and seabed preparation, geophysical and material engineering, installation services, cables and substations, the maritime operations through to the SOVs delivered for the O&M and the decommissioning of the projects. Norwegian industry can supply you with innovative solutions based on their expertise from the long expertise from the offshore exploration and production of oil and gas outside the Norwegian coast and also everywhere else in the world. We are therefore happy to be joined by 3 Norwegian companies today, highlighting some of the expertise that we deliver to offshore wind. First, DNV with their risk management and certification expertise, represented by Benson, Waldron, area manager for Japan and Taiwan, renewable certification within energy systems at DNV. Then we will see IKM Subsea with their remotely operated ROVs, represented by Ruben Subramaniam, who's business development manager there. Then the company Vissim, which is supplying maritime operational control systems, represented by Dent, managing director of Offshore Wind. Afterwards, later on, you will also hear Anna Hilton from Stone Geo speak about how to manage weather risks in offshore wind. Now, without further delay, I would like to invite Benson to be on the screen. Please, Benson, the screen is yours.
Okay, thank you very much, Jon. Appreciate the introduction. I think I do have some slides. Yes. So I'm Ben Waldron from, now it's there, from DNV, as you can see. Note the new logo. We've recently dropped the GL, so it's just become DNV. So I'm going to talk about managing risk, which is where we have a lot of experience for offshore wind. And within the crowd today, I was going to ask for people to give me maybe 2 or 3 of the main risks that they see for offshore wind in Taiwan. Any takers? Typhoon. Very good. There's no wrong or right answer, because depending on who you are and where you come from and your perspective, it may be very different. But typhoons, there's another obvious one in the room. Earthquakes, thank you very much. Anyone else? Sorry? Can't catch that. Your mask. Climate change, absolutely, yes. So these are many of the risks. There's also things for developers, such as the costs, schedules, so many others. So DNV, we were born in Norway 156 years ago, a bit before my time. And we're truly a global company, so covering 100 countries around the world, and very much involved in offshore wind, which these blocks down below show the four main business areas of DNV, all of which are involved in offshore wind in some capacity. So maritime, ships and offshore for installation, energy advisory, obviously connection to the grid, electrical machinery, software, digital solutions, everything from the design to the operation is now very much digital, and management systems, so the quality control of the systems. One thing we're very proud of is as a foundation, so DNV is a foundation, we're able to control our money, and 5% of our revenue goes back into research and development. So we invest a lot every year and run various projects that support various industries, but especially offshore wind, producing recommended practices. So here we've been running a joint industry project on exactly this, typhoons, earthquakes, as was mentioned earlier, and a recommended practice will be issued later this year. That was authored by Albert Koo, so one of our colleagues here, very much here in Taiwan. So very local. So yeah, across the project development cycle, we have various tasks and scope that we will do. So from the feasibility through development, engineering, construction, operation, you can't really see the little text underneath, but I'll go through some of the scope later. But the main thing here is that we're involved right from the beginning, when there may be a lot of uncertainty in a project, but very little investment, all the way through, hopefully with greater and greater certainty, but higher investment to the end, and different services for different stages of the project. And we pretty much cover all of it. Some of our customers, quickly, I'll go through this slide because there's project developers, owners, network operators, wind turbine manufacturers, and component manufacturers. So we've kind of grown up with the industry. We started at the very beginning. We've developed a lot of experience all the way through, and especially in the supply chain, which I'll talk about later with localization, is very important that there's a lot of trust between both the supply chain and the procurement departments. Anyone spot the mistake in this slide? I forgot a little bit of editing there. Never mind. So it's now just DNV. These are sort of independent energy assessment, wind monitoring campaign, METMAST inspections, market entry studies. These are all very early stage parts. I think I'm nearly running out of time now, but the shop approval, owner's engineer, marine warranty surveys, project certification, these are all tasks that we take throughout the project life cycle. These are the projects we've been involved with, so I think you'll be pretty familiar with all of these. We've been involved from the very beginning. Also worked closely with BSMI, the local regulatory agency, to make sure certification was very much fit for purpose for Taiwan. We also have local alliance partners, MRDC, CR, SOIC, that we work closely with and will be involved in projects to make sure there's a local experience as well as our global knowledge from wind around the world. Localization, spoke a bit about. We play a role here in making sure there's trust between the companies which are selling the products, and especially this drive to create a new industry here, and the buyers that are concerned about the price and schedule. And very finally, I think I might be slightly over time, but here we go, is there's a big push, and you've probably heard about this in the conference earlier, to get down the price. So this is the estimation for the curve to come down in 2030 to 54 megawatt hours, 54 euros per megawatt hour, and 35 in 2050. This is a massive change. And a lot of this will be from economies of scale as the industry grows globally, and there's a lot more going on. But there's also going to be bigger turbines, bigger farms, a lot more capital-intensive industries, a lot more risk. And that's where we come in, trying to smooth out the flow, so provide our experience to make sure we get there with as little bumps on the road as possible. So that was it, a very quick fly through of DNV's scope. Thank you very much. And now it's over to Ruben, I believe.
Thank you.
Let's change the screen.
Can you guys hear me?
Yes, we can. Yes, we can hear you. We're going to see you momentarily. Okay, here's. Sorry, this is Ruben's presentation directly. Maybe we will see him later.
All right. Hi, my name is Ruben from IKM Subsea. Can you change the slide for the second slide, please? Yes. Okay. Now it's clear. What we do, IKM Subsea is basically an ROV provider, which provides solutions to most of our clients and business partners in these areas, predominantly in construction support, rig support, inspection, repair, maintenance, decommissioning, and also renewables at this stage. Below are some of the support systems that we have in place for all our ROVs worldwide. I will touch more on the residential ROV on the following slide. Next slide. Okay, this is basically a footprint where we are worldwide, but I will not go into details. This is just for information's sake. So we can move into the fourth slide for me to elaborate more on how we're looking into the future. Okay, this is the roadmap on how we want to operate our ROVs for the next 10 years. We started off in 2009. We are the pioneers in terms of electrical ROV providers and builders, and also system providers around the world. We're also the prime movers for residential ROV. This is basically the ROV sits in the seabed for a couple of months until it's recovered back on the surface. And this is controlled by an onshore operation which is located in Norway currently. We would like to expand that from Norway into certain regions that we have offices in the world. So it is coming into Asia soon, hopefully, and we want to make sure that to reduce the number of offshore personnel. If you can see on the bottom side, on the left-hand corner, we currently have about 4 packs offshore and 2 packs onshore to operate the ROVs currently. But our objectives are for the future is basically to reduce to 0 offshore crew and to only operate with 2 packs in the office. These are some of the methods stated in the timeline, which are currently under research and development stage. So we would like to see our focus shifting from having many crews offshore monitoring ROVs to 0. So this is the objective that we are planning to achieve here. So next slide. How we want to do this is basically these are the 2 systems that we built and provide services with. The residential ROV is basically the UCD, which is on your left, and the normally used for offshore providers is basically on the right, the Merlin WR200, which is the older model, but it's still not old enough if you compare from the day we started in 2009 until now. Both systems are 200 horsepower systems. They are electrical propulsion. Like I said, we are the premier in terms of electrical providers in this market. Next slide, please. Where we are in Taiwan, at this stage, we are in the greater Changhua location on board the Norman Baltic. We are monitoring and assisting in grouting operations for our clients for all the 101 turbine foundation as we speak at the moment. So this is where we are right now, but we are looking into more offshore opportunities in Taiwan for wind farm operations as well. Next slide, please. Onshore control center. What are the advantages?
basically to have less people offshore. That is our motive, that's our target, and that's our objective that we want to achieve. By doing that, we also reduce a lot of carbon footprints, moving people back and forth, like it suits the current situation with the pandemic going on. So mobilization is a pain. So with having the onshore control center, you would not have issues in delays of getting guys offshore. So we can do it onshore itself. Plus, we also collect data on survey, on any video telemetries. We also can compile documents for clients who are onshore in the office as well, in real time. Next slide. So this is the RROV features. Residential ROV. At the moment, we've completed 13 weeks submerged in the water without any hiccups. We've managed to eliminate the need of launching and recovering period. So it's in the water and it works well for harsh environments. It has a radius of a 1 kilometer radius for it to fly around in the water as well. And these are all manufactured and designed by IKM in Norway. Next slide. This is the setup, how it's controlled from onshore. So if you can see, there's four ROVs which we are controlling at the moment from our office in Benson in Norway. And this is the same setup that we plan to do, but a bit of a modification that we are planning to install. Rather than having the fiber optic there, the next slide will show you the LTE capability that we have. Research and development at the moment. But while we have tested it and it's working, we are planning to do a demo test at one of our current projects in Malaysia at sometime in a few months' time. So hope to see that happening soon. So I would like to end my presentation with a video. I hope I'm in time. It's about a minute, I guess. So enjoy the video.
We are in the IKM Subsea Onshore Control Center, where we have just launched the resident ROV. It's We are in the IKM Subsea Onshore Control Center, where we have just launched the resident ROV. It's groundbreaking in the ROV industry. It's a work-class ROV placed on the seabed out in the North Sea. The ROV will be submerged for up to 3 months at a time. It does not require any personnel offshore to perform operations. And with all the personnel, the client representatives, third-party personnel in the IKM Subsea Onshore Control Center. This is great seats from an HSE perspective. You do not have the personnel offshore. You have a less carbon footprint due to the fact that you do not have to transport personnel offshore by use of helicopter.
That's all, thank you.
Very good. And now we have Nick Dent from Vissim.
Thank you, Robert.
I have to say the Norwegians are really on time, so it's great.
Well, it's great to join you remotely in Kaohsiung this afternoon and to provide a brief introduction to Vissim's contribution to marine optimization. Vissim has delivered 250 marine coordination, monitoring and communication systems around the world. And this includes systems for 27 offshore wind farms, where we reduce risk, we support compliance, and we drive efficiency in both construction and O&M phases. We're active in Asia, for example, at the Akita and the Shiro offshore wind farm. But it's a global industry, and in the past fortnight, we rolled out our new systems to a French wind farm. And this picture shows the temporary construction office. So what inputs are integrated into a marine optimization system? At the sensor layer, Vissim integrates data from tracking systems, AIS, radar, and ADS-B, LTE, Tetra radio systems, and this provides real-time information on the location of personnel, project vessels, helicopters, and other users of the marine space. With CCTV integration, operators can automatically acquire and follow targets of interest. And we also ingest data from environmental sensors, wave radars, wave buoys, met stations. And we present these in our unique real-time spatial representation interface. Let's fly past a little bit of the interface elements of the Vissim systems. So here we touched on CCTV. Here we can also see a working weather window layer, and this represents access probability based on parameters of environmental conditions and vessel performance. And here we have net forecast and the sensor layer. And this is really powerful data in the hands of your team when presented this way, and it supports consistent decision making. The heart of the Vissim system, though, is the fully integrated operation of VTMS and Offshore Energy Manager. So this highly secure role-based platform, shown here in Japanese, manages certification, inductions, and work authorizations. And your team can plan and execute changes in asset statuses, evidence these with uploaded documentation. The system also integrates work order and permit to work system data to display approved permits against any given asset. And in this way, manifests and plans can be quickly created using the drag and drop interface. And the whole process is supported by verification workflows, and there are automatic alerts, highlighting some of these, that identify conflicts in business processes, for example, simultaneous operations or a certificate issue. And uniquely within Vissim, this data is fully integrated and intelligently applied in the VTMS5 control room environment. Wind turbine generators, OSS, subsea assets like cables and pipelines can be represented with selectable GIS layers, and deviations from business rules are then visible at a glance. And this might be a vessel approaching an asset which has a restriction against it, or it could be people looking to transfer to an asset that has no live permit to work against it. And importantly, the operator can respond quickly from within the system, either to the vessel or the individual, and initiate communication. Given our short time slot today, let's observe here only that Vissim systems support and simplify the day-to-day activities across a wide range of the offshore wind players, and that this pays. It pays by distributing the administration of certificates and inductions to the end users, contractors, and what's more, all system components have been designed to enable remote and centralized management of multiple sites. And this allows efficiencies in workforce requirements, but also in the application of common operating procedures across multiple sites and shared learning. It pays by lowering the risk profile through asset protection and HSE compliance, and then by planning and monitoring activity within the same Vissim ecosystem. Deviations from your optimal plan are automatically identified. And finally, what's more, all events are recorded and stored for analysis and correlation, either within Vissim's own reporting server or your own BI platforms. So, if you're a wind farm developer, operator, EPCI, or you're a specialist marine management provider, or an associated Taiwanese business interested in partnering with Vissim in your market, we'd love to hear from you and explore how Vissim Marine Optimization can add value to your projects. Thank you, Robert.